Hi, in this presentation we shall talk about some of the projects of material masters in architecture to get some insights on why building materials are an important palette to architectural composition. So, like a painter that uses different media to express his thoughts and imprint his style into his paintings, architects uses materials to create an ambience and provide texture or substance to architecture, as can be seen in this rusty tin shed transformed studio in Sydney by Raffaello Rosselli, exemplifying material honesty. Recycling the original corrugated metal sheets as a material palette in this composition provide its rustic industrial character, while the glass corner window implies modern formality. The wood planks of the gate brings it closer to nature. In contrast, the Leslie Eldon Pharmacy Building by Foster and Partners for the University of Toronto, it features a 20-meter high colonnaded circulation daylit space as a hub of undergraduate activities, encouraging interaction between students. The main space owes its lightness and elegance through the use of glass and steel, as can be seen in its glazed facade made of frit glass. Its main attraction is the two reflective silver-colored pods suspended within the main space, which change colors according to the light conditions, with LED lighting illuminating the pods, casting tints of hues on its sleek glass facade amidst a towering concrete colonnade, provides a striking focal point for the building. You would see by the examples that different architectural characters can therefore be achieved through the use of different materials. Moreover, the availability of building materials dictates the construction methodology to be adapted for structural, functional, aesthetics, and of course, economic concerns. So for me, materials and construction for architecture is a matter of architectonics. To understand how to use materials effectively, a designer needs to have an understanding of precedent, or how materials have been used historically, and an awareness of innovations in material application. Both can provide a useful way to develop a range of design approaches. Thus, for an architect, a sound understanding of construction methods and practices is essential. The architect needs to understand the nature of materials and their possibilities and limitations before they can be used to create buildings and spaces. Therefore, both history of architecture and building materials and construction courses are important part of the architectural curriculum. And just to recall some of the types of building materials we covered on your history and building technology subjects, we discussed some of the types of materials, starting from brick and stone, concrete, timber, glass and steel, and composite materials. And to look back on our architectural history, here are just some of the chronology on how these materials were used. Starting from brick and stone as used in the Neolithic era, ancient Egypt, classical Greece and Rome, medieval times, Renaissance, and to the modern times, we can see that stone has long been associated with permanence and solidity, thus providing the monumentality in the architecture of ancient civilization. Of all materials available to the architect, it is arguably the use of stone and brick that produces an architecture most closely associated with its geographical and cultural context, like in the Ushino Stone Church by Kendrick Kellogg in his interpretation of organic architecture with the use of local stone, both for the interior and exterior. And also, to his sculptural high desert house with, of course, the help of interior designer John Bugrin. The entire structure was crafted from natural materials, as can be seen in the photo. Of course, aside from its main structural component of concrete. We could see that both stone and brick can be used in a range of architectural applications, as both materials have a load-bearing potential to support their own weight or even more. They are used most effectively in constructing walls and for floor surfaces. The Sagrada Familia by Antoni Gaudi, whose construction began in 1882 and is still to be completed hopefully on 2026, was designed to challenge ideas of structure and celebrate the most incredible craftsmanship. That is, to carve and transform stone from a solid static material to a dynamic, expressive surface. White concrete was used for pillars and the surrounding walls, whereas high-strength concrete is used for pilasters, foundations, and pavements. Inside the basilica are long columns of red porphyry volcanic rock, while the small and dark columns are made of basalt and granite columns that project the exterior light. This building exemplifies the potential that stone offers the architect and the real possibility its use presents to create symbolic, iconic, and memorable structures. This leads us to our second material, which is of course the Roman invention of concrete. From the Pantheon, the reinforced concrete of Auguste Perret, the pre-stressing technique of Eugène Freycinet, with the reinforced and precast concrete technologies of Pierre-Louis Guinervy, to the expressionist form of Le Corbusier with his béton brut aesthetics, to the geometry, light, sculpture, and minimalism of Tadao Ando, to the futuristic space-age form of Oscar Niemeyer, the captivating designs of Santiago Calatrava's architectural structures, and to the dynamic sculptural organic forms of Zaha Hadid. And the possibilities are limitless. You would notice that concrete offered the architects a material that could be molded to form new shapes, and one that, when reinforced with metal, could be used structurally to challenge ideas of building, form, and scale. We also have nature's best offering, timber. From simple thatch shed to the Neolithic longhouses of the Vikings resembling a ship, to the impressive intricate architecture of China and Japan, to England's Wilden houses for the human classes, to the complex facades of timber-framed Tudor houses, to the static effect of overhanging timber jetties, to the American craftsman style design of Charles and Henry Green for the Gamble House, to the factory-built timber frame houses of Huff House Company, which are individually crafted, to the remarkable glass and wooden structure of Ian Fay Jones, seen in his Thorn-Crowned Chapel with its rhythmic wooden columns and trusses, to the seemingly floating Odate Jokai Dome, in which the wood plays a crucial role in bringing comfort and warmth as it beautifully embraces the space, designed of course by Toyo Ito, and to the Carter or Tucker house that takes the form of a glass box, clad with slender cedar panels, designed by Sean Gadsell, to the dramatic, light, and airy structure of the Downland grid shell by Edward Cullinan Architects, and to the openness and transparency concepts of the Welsh Assembly Building by Richard Rogers and Partners, which was awarded the BREEAM Excellent rating for its environmental strategy, which includes boreholes, greywater recycling, and extensive use of natural light and ventilation. The partnership think that their design symbolized a new form of democracy of which the whole of Wales could be proud. To the timber arch supports of the wavy roof of Terminal 2 at Mactan Cebu International Airport, designed by Hong Kong-based studio Integrated Design Associates with support from local firm Buji Royal and industrial designer Kenneth Cobon-Pugh. It is obvious from these examples that timber is a versatile building material. It can be used to create a building skeleton structure or be utilized to great effect for external and internal finishes, thus offering the possibility to design and construct a building entirely of timber, from its frame and wall coverings to the roof. In addition to its versatility, timber is the ultimate sustainable material. If properly sourced, it can be grown, used, and replenished with little or no waste from its manufacture and production, as could be seen in the Aspen Art Museum by Shigeru Ban that has a ceiling entirely composed of interlocking wooden truss system. There is a matter of aesthetics to consider as well. Shigeru Ban's favoritism for wood also springs from an appreciation for its color, texture, and visual malleability. The main hall of his Nine Bridges Country Club makes use of timber columns that add a warmth and texture to the room, counterpointing the interior concrete walls. Timber also offers the architect more than just practical advantages. In an interview with the New Yorker, Shigeru Ban said that wood is the most ecological thing. Steel, concrete, we are just consuming from a limited amount. Timber is the only renewable material. Crucially, timber is a crop, and as such, it can be grown to replace and generate future reserves. This makes timber one of the most sustainable materials in the construction industry. As such, timber has responded well to the social and economical issues associated with construction and materials. The Consortium for Research on Renewable Industrial Materials has found that in life cycle analysis, wood outperforms steel by 17% and concrete by 16%. Further, timber is an aesthetically rich material that can vary depending on the tree's species and type. Additionally, it has a natural beauty that over time can weather, a feature which can gradually add to a design scheme. A timber finish is ultimately flexible and can be adapted to suit a great number of possibilities, taste, and applications, as we can see in these examples. Next material is glass and steel. From the humble beginning of glass from Syria to the use of stained glass in Gothic cathedrals, to the pivotal point of contemporary architecture through the Crystal Palace of Sir Joseph Paxton, showcasing the world's first prefabricated glass building constructed for the Great Exhibition in 1851, to the constructivist visionary architecture of Vladimir Tatlin for the monument to the Third International, and to the reductive approach of Mies van der Rohe for the Barcelona Pavilion, to his skin and bone metaphor for the Farnsworth House, and his less is more dictum of functional ideals as can be seen in the Seagram building, to the high-tech brutalist style of Piano and Rogers for their Pompidou Center, and to the cultural subtlety in Jean Nouvel's attention to facade detailing, a main feature and innovative element of the IMA is the advanced responsive metallic brise-soleil on the south facade. Nouvel's proposal for this system was well received for its originality and its reinforcement of an archetypal element of Arabic architecture, the mashrabiyah. He drew inspiration from the traditional lattice work that has been used for centuries in the Middle East to protect the occupants from the sun and provide privacy. And of course, to the minimalist expression of IMP for Platonic shape of the lower pyramid. And the high-tech glass dome of Foster and Partners for the Riksdag Parliament building, and their British Museum with its undulating minimal steel lattice work supporting around 3,312 triangular glass panels, aside from, of course, their skyscrapers using glass and steel. Another striking lattice work with its shell-like diagrid roof is the Western Concourse of King's Cross Station by John McAslan and Partners. And of course, the constructivist style of Frank Gehry for the Louis Vuitton Foundation Museum with its 12 immense glass sails supported by wooden beams. The sails gives the museum the transparency and sense of movement. As seen with these examples, glass and steel represent a manufactured form of architecture. These are materials that are used frequently in contemporary architecture to produce buildings that are both functional and practical. Yet, the aesthetic possibilities with glass and steel are impressive. The architecture that utilizes these materials can become almost invisible, framing views of landscape or sky, or transport us to the height of a bird soaring above a city. Glass is the material of the future and provides both practical and symbolic qualities of transparency, lightness, and openness. And lastly, on the types of materials are what we call composite materials, since their properties can be engineered to respond to particular design conditions. For example, they may be especially durable, strong, or waterproof, depending on the requirements. The key advantage of using composite materials in architectural design is that they are hugely flexible. By varying their composition and constituent parts, different solutions for different projects can be found. So, starting with Richard Rogers' machine-like aesthetics of the Lloyd's building, made of interlocking prefabricated elements, to the sculptural dynamic shape of the titanium-clad Guggenheim Museum in Bilbao, Spain by Frank Gehry, to the PTFE roof of the O2 Arena, again by Richard Rogers, to the Japanese Pavilion by Shigeru Ban, constructed with a long grid shell structure made from paper tubes, and to the ETFE glazed volumes of the Eden Project by Grimshaw Architects, to the chainmail aesthetics of Selfridges store, cloth with thousands of aluminum discs designed by Future Systems, to the blob architecture of Peter Cook and Colin Fournier for the Kanst house with its reinforced concrete framework covered with blue plastic to give its organic form, to the ever-changing media facade of the Galleria department store by UN Studio using 4,330 glass discs with dichroic foil and illuminated LED lights at night, creating a multitude of aesthetic effects. Composite materials have been adapted from their original form to create engineered hybrids that can serve multiple functions in building design. For example, materials that combine the aesthetic qualities of wood with the durability of plastic are now available, and that's because of the advances in material science and technology, as well as the sophisticated multiple functionality they can offer. Composite materials are often specified by architects as a substitute for costly natural materials. Composite materials from plastics, as with the ETFE-clad Beijing's National Aquatic Center by Arup and PTW architects, to carbon fibers, as with the University of Stuttgart's pavilion made from advanced fiber composites of carbon fiber reinforced plastics. The future of composite materials in construction is bright, as material technology allows us to better understand their potential. The application of composite materials in new contexts is growing. Many of these materials find their origins in areas outside of architecture and construction. But inventive thinking and cross-discipline collaboration is bringing them into the world of building design. This idea of collaboration was popularized by Charles Eames and Ray Eames in 1945. In the post-war housing problems of America, they designed case study house number 8 in an attempt to reemploy workers and factories that had supported the production of wartime armaments and aircraft. The design of the Eames house responded to ideas of mass production, composite parts, and rapid assembly. In the Eames house, most of the materials were prefabricated and shipped to the site, where a construction crew of 8 men assembled the 11 tons of factory steel and glass in just over a day and a half. The overall cost approximately $1 per square foot during that time, or about $10 per square foot today, or roughly around 5,000 pesos per square meter. Their materials include concrete, ferroboard, cemesto, glass, Voltex, paint, plyon, plywood, tallow wood, wood floor parquet, rubber or vinyl tiles. They accomplished this remarkably low-cost house using relatively inexpensive prefabricated materials and by compartmentalizing the design in order to simplify construction. And to conclude, we take a look, of course, at our featured front cover, the Jubilee Church, designed by Richard Mayer. The church showcased a masterful interplay of glass, stucco, Roman travertine, white concrete, and wood paneling to achieve an architectural masterpiece. The commission was won in a competition against other masters in the person of Tadao Ando, Santiago Calatrava, Peter Eisenman, and Frank Gehry. Its most distinctive feature is the 3 curved shell walls or sails made from concrete shells with marble-like finish, reinforced with steel, and are held together by post-tension cables horizontally and vertically. The 3 circles of equal radius generate the profiles of the 3 concrete shells that, together with the spine wall, make up the body of the nave. These freestanding sails symbolizes the Holy Trinity and are designed to withstand forces of nature from heat, wind, and of course earthquakes. The materials used in the portico, the paving, the wall cladding, and the liturgical furniture allude to the body of Christ Church, while referencing the fabric of the adjacent residential area. In the interior, indirect sunlight filtered through a series of glazed skylights suspended between the shells are lit by zenithal sidelight, and the nave is enlivened by a constantly changing pattern of light and shade. The light is also diffused over the inner volume of the church and varies according to the hour, the weather, and the season, imparting a particular character to the aspects of the interior. The interior materials of light wood paneling and simple beechwood pews contrast with the stucco organ loft and the white cross. The roof of the nave and eastern and western facades are glass, while the altar plinths, baptismal font, and the altar are made from travertine, similar with the nave floor. In the Jubilee Church, from the words of Mayer, the three concrete shells define an enveloping atmosphere in which the light from the skylights above creates a luminous spatial experience, and the rays of the sunlight serve as a mystical metaphor of the presence of God. So, indeed, materials create an ambience and provide texture or substance to architecture. With the plethora of available materials in the arsenal of architects, extending the possibility of design potential, we need to look at future directions of using materials considering innovations and sustainability. Thus, smart materials that are energy efficient as well as nanotechnology, among others, should be explored by the designers as part of their ever-changing palette. Thank you and have a pleasant day.